In this review video, we are going to work with increasing and decreasing, and then we'll also talk about absolute value equations and inequalities. In this first problem here, we are being asked where the function f of x equals 3x cubed minus 9x is increasing only. Well, the first thing that you need to do is you have to graph this thing. So you have to graph it to see what exactly it looks like, where are its turning points. So I've already done that, and I have put the picture of the graph right here, and let me kind of blow it up a little bit. This is what it should look like when you graph it. And remember that if your zoom is screwed up, that you want to do zoom standard so that it will fit in the screen perfectly. And this right here is a turning point. So this is a turning point, and then down here is another turning point. And remember that your turning points are where the graph switches from increasing to decreasing, and then vice versa. So if we're looking at this, there are arrows. This thing goes on forever. So as we are tracing this and looking through the graph, remember you want to read it left to right. So you would go up until you hit that turning point. And so that interval right there, that is increasing. And so this would be from negative infinity until you hit what x value? And that is the x value of 1. So from negative infinity to 1. And then we decrease, so we don't care about that part. But then once we hit this point, we start increasing again, and we increase forever in the other direction. So when we start here, this is the x value of a positive 1, and so we're starting at 1 and going off until infinity. And I guess actually these should have brackets on them. I should fix that, sorry. So when we're looking at our answers here, they are not in interval notation. However, this negative infinity to a positive or a negative 1, good Lord, I'm screwing that up. Sorry, guys. That would mean that x has to be less than or equal to a negative 1. And so what that does is rules out A and B, because this is an equals, and that just doesn't even make any sense, and this one is just less than. It's also in between the two, which isn't correct. So when we're looking at these two and the difference between these two, again, you're looking at the inequality signs. Well, C has the correct inequality sign because that's where it is in fact increasing. And so then again, when you hit this point right here of a positive 1, so you're going from 1 to infinity, you would do, you would say that it would be x is greater than or equal to 1. And so there would be your or with your two pieces to it. All right, now number 2. This one I did not give you the actual graph for, and I don't want you to put it in your calculator. I want you to try and remember how to graph this thing. So first of all, there's an x here, and then this is x squared. So all together, this is an x cubed function. So it's odd, which means that the ends go in opposite directions. Well, if the ends go in opposite directions, but that first term is negative, so the leading coefficient is negative. All right, so here are our pieces of information. It's odd degree, ends go in opposite directions, and our leading coefficient is in fact negative. So odd degree would mean it's going to, oh, and then turning point, sorry, because the degree is 3, that would mean that our turning points are 2. There's 2 of them. All right. So that means we are going to, this is what I'm working for right here. Okay, the coefficient is negative, means that it will be decreasing the whole time. So when you go to graph this thing, x minus 1 equals 0, which means x equals a positive 1, and that is a 0. X minus 4 squared, so x minus 4 equals 0, means that x equals 4, but this has a multiplicity, so multiplicity of 2, and that is because of this little thing right here. So that means that it's going to bounce off of the x-axis and just hit it and turn. And so we're going to go to x is 4 and put a point there. So since it is decreasing the whole time, I'm going to start here and then it turns and bounces and goes back down in the other direction. Okay, so this was just a reminder on how to actually graph this thing, but what we need to know is where is this turning point actually happening, right? So we want the increasing intervals, which if you're tracing this, this is decreasing, decreasing, decreasing until you hit this point, and then it goes up and it hits that point right there. And so once it hits that point, it starts to decrease again. Well, we don't want the decreasing interval. And so what is this exact interval here? Well, from what it looks like, it's between 2 and 4. So that would be G. To get it more accurate, you would use the calculator and you'd be able to get the exact point. All right, so again, another one where I didn't give you the exact spots or the exact graph. So I want you to start with, this is x squared, this is x and x, so there are 4 total. So it is an even degree. It is 4, so the degree is 4. So that means that the ends go in the same direction. It's the same direction, and our leading coefficient is positive. So if our leading coefficient is positive, then that means both ends go up. Since our degree is 4, we can only have a total of 3 turning points. And then I think that's really all we have to worry about. So we're going to start with our x plus 1 equals 0, gives us x equals -1 as a 0. But this little 2 right here means that we have a multiplicity of 2, which means that it bounces off of the x-axis. It doesn't actually cross it. So I'm going to go to -1 on the x-axis and put a point there. Then we get x minus 1 equals 0, which means your next x-intercept is at a positive 1, and then x minus 3 equals 0, which means x equals 3 is your other x-intercept. So as we draw this, we start with going down, and we bounce, and then we turn and we go back down again. But this time we cross and we come back up and cross through our last intercept, and there's your graph. So now we're looking for where this is decreasing. So we are decreasing until this point right here. And then again, we start to decrease somewhere in this point right here. So now to get a more accurate interval, you would graph again. So more accurate, you would graph it on the calculator. Just because then you can trace it and see what's going on there. But there really is only one answer that gives you any interval that fits this description. Between -1 and 3 would be somewhere in here, and it's not even decreasing that whole time. Less than -1, while it is decreasing from -infinity to a -1, it doesn't only decrease there, it decreases in this interval as well. And so that's not it. And then this one between -1 and 0.2, it doesn't decrease there at all. And so C would be your answer. Now with number 4, we're looking for the intervals again where it's only decreasing. So I'm going to show you and kind of remind you how to do this on the calculator. So what you have to do is go ahead and graph this function, and this is what happens when you graph it, and it doesn't quite fit in the screen. So if you hit zoom and you go down to zoom fit, let's try. If you go to zoom fit and try to get this thing in the screen, it zooms out like really far and you can't even really see what's going on with the graph. It's really confusing. So I'm going to go back to zoom standard. So instead of doing that, I want to know where this point is down here. So instead of doing that, I'm just going to change the window. My top point fits just fine. I'm going to make the Y value lower. So I'm going to hit window, and I'm going to make the Y minimum -30 instead of having it at a -10, and then try to graph it and see if maybe I can get that turning point in there. And there it is. So changing the window pulled the turning point up. So now you would trace. And what you want to do is do second trace, and you want to go to, for the first one, the maximum value. And so you want to be on the left side and hit enter, go to the right side and hit enter, and then as your guess, just put enter. And so you get negative 0.99 repeating and 7. So basically it's negative 1. So we have a graph that looks something like this right here. And at this point, x equals a negative 1, and we want to know what that one is. And so again, I'm going to go ahead and pull the graph back up. I am going to trace it. Sorry about that. But this time, because we're doing a low point, I want to do a minimum instead of a maximum. So I'm going to go to minimum, and then I'm going to move along the graph until I'm on this end over here, hit enter, and then go to the right side of that turning point and hit enter one more time, and we get 1.999 repeating, which is basically 2, and so that would be x equals positive 2. And so decreasing would only be in this section right here of our graph, which is between negative 1 and 2. And so our information given to us is h, negative 1 and 2. All right, so number 4, again, graph it, pull it up on your calculator, and I want you to do this one on your own so that you are able to get used to the buttons. And this is the window setting that I use to make the graph look like this. So change your window settings and mess with them and get your answer for number 5. All right, so now we're going to talk about absolute values pretty quickly. But if we are looking at absolute value equations, we need to split it into 2 separate equations. One of them is going to be x equals 7. The other one is going to be x equals negative 7. So that would be D as your answer. Number 2, we are looking for which one describes this graph. Well, what we have to do is we have to work with the answers, okay? So work with answers. We're going to solve each. Now I'm going to get you started, but I want you to finish this problem on your own. So let's say we're working with A. When we have negative 3 times the absolute value of 4x minus 1 plus 7 is less than 2. You need to isolate the variable completely. I don't know why I just wrote minus 2 there. Sorry. Minus 7. So you need to start with solving this as if it were a regular equation to begin with. So we get negative 3 times the absolute value of 4x minus 1 is less than a negative 5. Then you need to divide by a negative 3. And dividing by a negative 3 is going to leave this as the absolute value of 4x minus 1. This sign is now going to flip because we divided by a negative, and a negative 5 over a negative 3 is a positive 5/3. Well, now is where you split into your 2 separate inequalities. The first one will be 4x minus 1 is greater than 5/3, and the second one would be 4x minus 1 is less than a negative 5/3. Then you solve both, and then you check to see if the answer fits the given graph at the top. So I want you to finish that one on your own. All right, number 3, so what's your solution in this one? So I'll just go right ahead and get you started. So 2x minus 3 inside the absolute value, minus 1 is less than 3. Isolate the variable first to get the absolute value of 2x minus 3 is less than 4. Then we split into the 2 separate inequalities. So we don't want to start that way. So we do 2x minus 3 is less than 4, and then 2x minus 3 is greater than a negative 4. Add 3 to both sides of your inequality here to get 2x is less than 7. Divide by 2, and you get x is less than 7 over 2. Over here, add 3 to both sides of your inequality to get 2x is greater than a negative 1, and then divide by 2 to get x is greater than a negative 1/2. Remember that the sign only flips, so only flip the sign when multiplying or dividing by a negative. Okay, so here I did not divide by a negative number, I divided by a positive. So we're looking for the solution that's less than 7 over 2, but greater than a negative 1/2. So less than less than, so D is out, less than a -1/2, which is not going to be that one, but greater than 7/2. So actually C would be